Now we're going to talk about graphing quadratic functions, and that shape is called a parabola. All right, so when you look at a parabola, there's some very important features to talk about. Okay, there's either going to be a minimum or maximum that we call the vertex. The vertex is also the center of the graph. A parabola is always symmetrical, okay, around the vertex. So imagine there's a vertical line. Okay, coming down here, this line would be called the axis of symmetry, often abbreviated AOS, okay, for axis of symmetry. The left side is going to be a mirror image of the right side. So that helps us graph because once we get one side, we automatically already know that the other side is going to be a reflection across the axis of symmetry. The other important thing to know about quadratics is that the function can be written in three forms. Okay, standard form, vertex form, and factored form. They all tell us something a little bit different about the graph. And so when you're given standard form is the least helpful when graphing. It does, the A in all of these always stands for the same thing though. The A tells us the direction, so a positive A is going to be going up like this one, a negative A that'll be turned upside down. So A always tells us the direction, and it's also the scale factor. It's going to stretch it out or compress it, just like we learned with transformations. All right, but with standard form, the A tells us that, and the C tells us the y-intercept. So whatever the C is, that's our y-intercept. The B doesn't tell us anything directly, but it does help us find the vertex. We'll go into more detail about that in a second. And then vertex form, which I believe is the easiest form to graph from, because it tells us the most important point on the graph, which is the vertex, because it's the center, it's the min or max, right? It's where the axis of symmetry is. There's other important parts like x-intercepts and y-intercepts, but the vertex is probably the most important point of a parabola. And so the vertex form tells us, again, A, the same thing, but H and K, okay, are the vertex. So this H in here is the x-coordinate of the vertex, and the K is the y-coordinate. Okay. Factored form is also useful. Okay, the A tells us the same thing, and the P and Q's in here are going to tell us our x-intercept. So when it's x minus P, okay, P comma 0 is an x-intercept, and when it's x minus Q, Q0 is an x-intercept. So what's going to make each factor equal to 0 will be an x-intercept. All right, so factored form gives us some important information, but not every graph has x-intercepts, so not every graph can be written in factored form. But every graph can be written in standard form or vertex form for a quadratic. The other really important thing that I want to notice about a quadratic that it always follows the same pattern. So when I start at the vertex, if I go over one, it's always going to go up one. If I go over one from that point, it's always going to go up 3. And if I go over one from that, it's always going to go up 5. All right, so you can see it's going to follow a pattern of 1, 3, 5. And I used the word always when I was talking. I probably shouldn't have. Okay, that's the parent function will always. But as soon as I add an A that's something other than 1, I'm going to start stretching that. That's what the scale factor does. So it's going to have the pattern of 1, 3, 5. And then the next one will be 7 and then 9. But that could change when I have an A other than 1. So if I make A2, then the pattern will be 2, 6, 10. Right? If I have a pattern of 1/2, it'll be 1/2, 3/2, 5/2. So my A will control that pattern. So out of all these here, again, I believe the vertex form is the most helpful to graph, but they all help us with some key feature.